Hi guys, this is 2023 AMC 8 problem 19, and we have this geometry problem here, which I believe is a pretty classic geometry problem. So to do well in the AMCs, you should probably know how to do one of these. So it says an equilateral triangle is placed inside a larger equilateral triangle so that the region between them can be divided into three congruent trapezoids as shown below. The side length of the inner triangle is 2/3 the side length of the larger triangle. What is the ratio of what is the ratio of the area of one trapezoid to the area of the inner triangle? Okay, so we see here that we have one equilateral triangle inside of another, and because each of these three trapezoids are congruent, we know that they share the same center here. And so then we can honestly just basically calculate the area of the larger triangle minus the area of the smaller triangle and divide that by 3 to get the area of one of these, and then find the ratio with this inside one, right? So I think it's pretty straightforward. Let's say the side length of the larger triangle here is 3, and this one is 2, and it really doesn't matter what numbers you choose as long as they're one of them, like this inside is 2/3 of the other, since we're looking for ratios, right? And ratios, we don't need these like predetermined numbers. Instead of this, we could have done like x and 2/3 x. Either one works. These x's will be canceled by the end. So I think it's just easier to establish like in concrete numbers. So I don't know if you know this formula, but there is a formula to find the area of an equilateral triangle, which is √3/4 s squared, where s is the side length of this triangle. Why is that? Well, this is really easy to derive here, as long as you know the base times height formula. So if we know that this side length here is s, then what we need to know is how to find the height, right? And in a um, equilateral triangle, we know that when we cut this triangle in half, it creates this 90-degree angle, which is true for all isosceles triangles, not just equilateral triangles. And we know that this forms a 30, 60, 90 triangle, which, if you know, has this special property where this length here, this length of the hypotenuse is twice the length of this, and this height here is √3 times the length of this side here. So this is like just like basic knowledge that you should know before you do like any competition geometry problem here. So if this length was s/2, this length would be s, and this length here would be √3 s/2, right? Since it's √3 times this side length. Sorry, that's kind of messy. So in order to find area, we would do base times height over 2. Sorry, base times height over 2. So it's base is s times √3/2 s over 2, which equals √3/4 s squared. So now that we know that, let's just quickly get rid of all this and solve. So using what we established as 3 and 2, we know that one of them, the larger one, would be √3/4 times 9, and the smaller one would be √3/4 times 4. So I'm just going to keep the √3/4 and say it's 9 minus 4, right? Distributive property, 9 minus 4, 5 times √3/4 is this area here. Sorry, all of these areas combined, right? They're different. And to find one of these, we would do divided by 3, right? Since there's 3 of them, and they're all equivalent. And we want to find the ratio with this inner triangle. And this inner triangle we've already found out has this area. So our area should be 5 √3/4 over 3 over √3/4 times 4. So let's cancel this √3/4. And then we know that this equals 5 over 3 times 4. So our ratio should be 5/12. So I believe the answer is C. All right, thanks, guys.